now that we understand callbacks and what callbacks look like and some of the issues we may come across if we start to kind of chain callbacks together, let's take a look at an alternative approach, which is promises. And promises are pretty neat. And you can sort of think of them as an alternative way to do asynchronous computations compared to something like a callback. So promise, and let me add my comment in here. Let me quote the Mozilla Developer Network here, where they say a promise is a proxy for a value not necessarily known when the promise is, and I'll put this on a separate line actually, when the promise is created. Right, and that's Mozilla Developer Network. In other words, when you call a proxy, you may get a result back immediately, you may get a result back later, or you may get a result back never. Right? There's a couple different possibilities. Right? So promises as well. Promises, similar to callbacks, are used for async computations. And think of it as a value that may return immediately or may be available now, later, or never. Right? And just for clarity, I might say think of a promise as representing a value that may be available now, later, or even never. And it's kind of like a callback in a lot of ways, actually, because you can associate a handler, so can associate a handler with an async action. And it's kind of in the name, so it's a promise. And if you think of what a promise is, it kind of makes sense when you see it in action. Basically, something else we need to know, though, is that a promise exists in these states. So it can be pending, right? So this is the default initial state. Promise is not fulfilled, nor is it rejected. That tells us it could be fulfilled, which is okay, got it, or it could be rejected, right? In other words, it failed. And I meant to type 3 here. And that's all great, but doesn't really make a lot of sense until we see some examples, in my experience anyway. So let's do it. Let's say we can do something like this. So const test promise, for example, and we basically construct it using the new keyword. So new promise, as if we're instantiating any other type of object. And we actually give this promise object a couple callbacks of its own, right? So it's good to know about callbacks. And generally these are called resolve and reject. And as we see, we're giving the promise object a function, right? So this is the same as us writing function blah blah blah, but I'm doing it the ES6 way instead. Okay, so we are creating a new promise, and what are we going to do in our promise? Well, let's just do a console log as usual. So we want it to be async. So let's do another timeout, set timeout, and let's see here. Let's have it take a second. This is kind of what we've been doing here. And let's invoke our callback. And we'll do resolve promise OK. So it's going to resolve to a string. And we'll take a look at reject later. Reject is usually used if you want to obviously reject the promise. Now, the way we can invoke this is we need to use the then keyword. So we've assigned it here to be the value of a new promise. And that means we need to basically invoke it. So the test promise dot then, and here we give it basically the callback. Right, so we're giving it a callback at this point. And this is our resolve essentially. So we could say something like resolve message. Right, and here we will do console.log. Actually, let's do some backticks. And looks like, and we'll interpolate it, resolve message. Okay, so let's see if this works. Run. After a second, looks like promise, okay. Now, what if we want to do some kind of asynchronous computation? Right, that's kind of what promises are here to solve for us. Recall up above, if we had to do that the old-fashioned way, we would just pass in a callback to the function. We do a set timeout here, we wait for that logic to run, and then we invoke the callback. Well, with promises, it's actually a bit simpler. And just to see what happens now, if we try this, console log, I should run after the promise is resolved. Let's see what happens. As you probably expect, this just runs immediately because we're still waiting for the promise to resolve. Right? This one waits, and then once it's resolved, we do a console log. Now we could solve this by just putting the console log in here, of course, but that defeats the purpose of us chaining these then statements together. So instead of doing that, I just add another .then on here. And it's going to take in a function that I'm just going to not pass any parameters to. And then we say console log inside this then statement. And these, you can chain as many of these together as you need. Right? So as it stands, we will wait for the promise to resolve. After this logic is done, then we will do another block of code here, right? Another function. So let's see what happens. Let's see if this works as intended. We wait, and then, okay, cool. That's exactly what we wanted to have happen. Right? So we don't need to worry anymore about passing in a callback to be invoked when certain logic is completed, because it's a lot more intuitive now, I feel. It makes sense if you read this code. Okay, I'm going to do this, then I'm going to do that, then I'm going to do something else, right? We can chain these together. So if I do another then statement, console log, promises are awesome. And I spelled R wrong. And let me try that again. Right, so we can chain as many of these together as we need. Pretty good stuff, right? Another neat thing we can do with promises is we can reject the promise. So if we want to see what that looks like, well, let's do just kind of a simple math.random that's going to reject some of the time to see what happens. Because it's possible for promises to be rejected. And this would happen, for example, if you're trying to, I don't know, access an external API and you don't give it the right parameters, it might reject that promise because it doesn't have the proper info it needs. And if we do some kind of statement here, if math.random, when you call math.random, it gives you a random number in between 0 and 1, essentially. So if we do if math.random is greater than 0.5, so about 50% of the time, we will reject the promise. Promise, no good, rejected. For example, right, this is just what we named the callback. So if math is random, we will reject it. And all we need to do is we can add a .catch statement in here, which will catch it when it rejects. And whoops, I erased it by accident. .catch, and I should probably say .catch. It will catch any rejected promises, and then we can do some other logic. So for now, we'll just do our usual console log. We'll say error, and we'll take in the reject message. Error, reject message. And let's see if we can't catch any rejected promises. And I don't think I need to chain this extra .then there, so I'm going to get rid of that actually. Okay, there we go. Let's try that. Error. Okay, cool. We got a rejected promise on the first try. Right, so we rejected it, and we just have to say .catch somewhere down the line to catch that promise. We don't have to worry about where this goes really. For our implementation right now anyway, we just say .catch. If there's a rejected message, we catch that. Let's try it again. Okay, this time the promise went through okay. I guess math.random was less than 0.5. And again, I would just say this to me is a lot more human readable than just kind of a bunch of callbacks somewhere inside of a containing function. Let's write another promise so that we can simulate the callback we did up above here. Right? So our sum up numbers function, which took in not only numbers, but we also had to pass it a callback. And let's see if we can't rewrite that in a more promise type way, a more human understandable way. So we're still going to do a function. We'll do function. I'm just going to call this num adder, for example. And you know what? I'm going to comment this code out so it doesn't run. Num adder. And we're just going to take in number 1 and number 2. I'm not going to worry about passing in a callback because we don't really need to worry about that. Instead, what we will do is within the function, we will return a new promise like so. And promise, we will give it a function that will take in resolve and reject. Right? And we will say const added nums equals n1 plus n2. Pretty straightforward. We're going to do our typical set timeout. And we will just, let's see, resolve with added num. So we're not resolving with a string, we're resolving with, well, this will just be a number, but this could be an object, this could be any data type you need really. And we'll take 500 milliseconds for this one. Okay, so we have our function. Now how do we invoke a function and pass it arguments, parameters, and then wait for the promise? Well, very simply. Num adder, and the arguments it needs are numbers, so we'll do 100 and 23. And then we just say dot then. We're going to get back some kind of data like so. And we can console.log the data. So added total data. Right, let's try this out. Run. Boom, success. Pretty easy to do, right? We don't have to worry about, hey, what is this callback we're getting passed in? Right up here, it looks simpler to the naked eye, but we had to define 2 separate functions just to take care of this simple asynchronous action we wanted to handle. Whereas down here, we just return a new promise in this function, and then we wait for it. And if you only have one argument or parameter, you can just remove those brackets as well, and it'll still run all the same. Matter of personal preference, really. I mean, you could even create multiple promise functions if you wanted to, and then chain those together. So for example, we have num adder, and then we can have function num squarer, and it'll just take in a number. Right, and we can return a new promise here as well. Return new promise, resolve, reject. This one will do set timeout. And what we'll do is we'll take 800 milliseconds on this one. And this one will resolve num times num. Okay, cool. So let's do something with the data we get back here. Right, so instead of just returning, we can do something like invoke num squarer with the data. In fact, let's return that. So I'm going to say return this dot then. We'll get even more data, and we'll console.log more data. Let's see what happens. Run. Interesting. So I'm not sure if that's correct. Maybe we should use some smaller numbers. So we'll do 10 and 10. It's going to add them up, and then it's going to square them. Run. Success. Right, square root of 400 is of course 20, which is what these would have added up to when we added them up. Right, so we're chaining a bunch of promises together even though they're technically in separate functions. Pretty neat, right? And in terms of how this looks, you might see something like .then is put on a separate line. That might make it easier to understand. And then we can say this should be on a separate line on its own, for example. But anyway, this is similar, right? So just to walk through what we're doing, we invoke numadder. Numadder takes in two numbers and returns a promise. We wait for the promise to resolve. When it does resolve, we get some kind of data back, right? We pass through our added numbers in our resolve callback. That's what I call data here. Here we return another function, numSquarer, and we wait for that to come back. Once that comes back, we invoke this .then method, which just console logs out the number. And you do want to return here, by the way, because if you don't, it's just going to be undefined at this point, right? Just to demonstrate that. So we want to return that. And that way we have access to it when we get to our next .then statement. Now, using the power of ES6, we can actually make this a lot easier to look at as well. Recall, as we've seen already, that if you remove these curly brackets, that creates a return statement without having to use the keyword return. Right, so that's pretty nice to look at. We just say data, do this, and then return this. That's why I can omit the return statement. And you know what? We can do the same thing down here. So remove these brackets because we only have one parameter. And we don't need to return, or we don't need to use these curly brackets if we just intend to return a console log statement, which is totally fine in this example. Let's run it. Still works as expected. And if we want to kind of play around with catching rejected promises as well, we can do the same thing. So if math.random is greater than 0.1, so this is going to reject most of the time. And we can just say reject, nope. Right, in which case, remove the semicolon here, and then we say .catch and error, and we can return from this as well. We'll just console.log the error. Okay, let's see, run, nope, rejected. Right, this time it won't reject as often, but it's still rejected, rejected again, and it's rejecting a lot, but that's fine. Right, it won't reject every time. We've just been unlucky a couple times. There we go. Right, and catch will basically catch either of these if either of these promises throw a reject statement. So to test that out, right now we have one on numSquarer. Let's just do a generic, right off the bat, we'll just reject. Not today. And let's see what happens. Run, and we just rejected right off the bat. On the first one, we don't even get to the second then statement because it just goes to our catch, which is our rejection handler. And I just got rid of that. And you know what? We don't really need to reject in this one either. Another neat feature of promises is that if you know you will be resolving, you can just hard code a resolve. And it's kind of a shorthand for doing something like using this constructor pattern. So new promise, resolve, reject. So instead of saying something like new promise, resolve, reject, and then you just resolve every time. So instead of doing this, we can use the shorthand promise.resolve. And this will allow us to just always resolve our promise if we want to, and we can also pass in whatever object we want to resolve with in here, be that a string, an object, an array, or whatever. Right, so here we can say promise.resolve, .then, give it a function here, and just console log something like so. Right, so that definitely works. Promise.resolve, you can of course pass it a string as well, right? And then we can access that here. So I'm just going to call it data. And if we want to console log that data, we can easily do so. And looks like looks like it worked. That means if we have a function, we always, we want to make our function return a promise. So always resolves, and we always want it to just resolve. Well, that's very simple. We will just return promise.resolve instead of constructing using the new promise method. Right? I love resolving, for example. Then of course we can say always resolves dot then do something with the data we get back. Right? Console log data. Cool. And we haven't explored too much in terms of our resolve object, but we can of course do various types of objects in our resolve statement. So if we had something like const, let's just call it prom to represent promise equals promise.resolve, and let's give it an array of numbers, for example 10, 20, 30. We could do something like prom dot then. So we know that prom is going to be equal to a resolved promise. Therefore, we can call then. We can take some nums. I'll call it nums. And we can return something like nums.map. And we are going to map over each num. And we can do like so, actually. So ES6 makes it easy to write concise code like this. And we can do num times 10. And we can keep the then chain going. So you know what, I'll put this on its own line. And I'll say dot then transformed nums. And we will return a console log showing those transformed nums. Let's check it out. Cool. And we could keep this chain going as long as it needs to be. Don't really need to worry about catching because we know that prom is equal to a promise.resolve. On the other hand, if we did something like const another promise.resolve, and we give it an object, which is common if you're doing kind of external API requests, you might get something like text resolved, like so. Right? And now we can say another prom.then, and we'll get data, and we can console log data dot text. If we try just to do data, it's just going to be an object in our console. Looks like you didn't quite catch it there, but there we see it's an object. So we want to access the text key, and there we go. Right? And if you're wondering why this text is showing up before our numbers, well, it takes a second, or probably a lot less than a second, but it takes some time to map over the numbers. So while this is happening, we just move along and run this code. Now, in terms of rejected promises, I did want to mention that we can catch them in a slightly different way. So if we do something like this, so promise.reject, and I'm not going to give it a reject message, but we know we can say dot then do something. I'll just do console log, okay, or we could do dot catch, and we know dot catch will work if we console log caught rejected promise. For the sake of consistency, use double quotes here. So we know that we will catch a rejected promise this way. We could have caught it a different way, and that is if we pass a second argument to our initial then statement. That is another way that we can catch rejections. So we could instead have done it this way. We could say, okay, if we get a response, we can return something here, like so. So you know, we'll put this on a separate line. So if we get a response, let's console log the response, or comma, we could get an error, and it's common to call it error. You might see, you know, on rejection or on rejected or something like that. But here we can console.log rejected instead. Right? Not rejected. So let's see if this works. Run it. Okay, it looks like it did work. Now there are some slight differences here that at this point we don't really need to worry about too much, but all we need to know really is that the differences here, we're adding an error handler, you know, or a rejection handler on the initial then statement, whereas if we add a catch down here, we are catching, well, it's kind of a catch-all. So we catch on the original promise or on the then statement, whereas this one is kind of internal to the then statement. So, we'll throw a catch statement in here, and let's see, we'll call it data, console log that data, and let's see what happens, right? We have it on the initial rejection statement, so we don't even ever get to this point. On the other hand, if our then statement in here had a promise we were waiting on, so instead of promise.reject, let's do promise.resolve, and let's just observe what happens. Oops, it should not say rejected. Let's try it again. Not rejected. If instead, let's say we did another promise.resolve in here, and actually let's say we try to do a promise inside our response, but it gets rejected. Let's see what happens at this point. Rejected inner promise. Run. Okay, so at this point, we didn't get to this code, but our inner promise has failed, so we catch that one afterwards. So again, we don't really need to worry too much about the difference, but if you do have, say, an internal promise or some promise nested somewhere down the line, you probably need to catch it at some point. Otherwise, you can just catch it inside your initial then statement. We'll explain that one more time just for the sake of clarity. So promises are chained together. Right, so what's happening here is we get a rejected promise and we say, okay, when we get this promise back, do something. And if it's successful, we will do this. If it's unsuccessful, the second argument is always kind of an error or a rejection handler. In this case, we are console logging rejected. This catch will catch any and all errors that aren't handled, inside the then statement, for example. Now, if on our response here we threw an error or rejection, so for example, we can say return promise.reject, and if we change this one to resolve, right? So our rejection handler will run. We didn't pass it any message or argument here, so it's just undefined. But remember that these are chained. So if instead of just a general catch-all, we wanted to, just in case, be able to catch something from the initial then statement, well, it goes then, this logic runs, then something else will happen. Right? So then we can do the same logic in here. So then response or resolve, do something, console log cool, comma, if there's an error here, then we can do something else, right? So let's console.log inner promise rejected. Okay, and as you might expect, what will happen is we won't reach the final catch statement because we chained this on after the initial then, and we should be able to catch this rejection. Let's see. Okay, inner promise rejected. Cool. So subtle but slight difference that I think we should definitely be aware of. So now that we have some understanding of promises, let's see if we can't rewrite our initial timer function, which was, where was that? Here, at our counter. This was kind of a nightmare to look at when we were doing callbacks, right? So we have all these nested brackets, for example. Let's rewrite this using promises, and it's simpler than you may think. So basically, we can write a function. I'll just call it time logger. And what it's going to take is it's going to take in a message and a time that it will take to execute. And what we'll do is we will return new promise, and we'll do resolve reject as usual. And in here we'll do a set timeout, and the set timeout will take whatever time we pass in. It's going to take that long until it executes the timeout, and the timeout we will resolve with the message that was passed in. We can also say here if message is not equal to string, so we'll say type of, it's not equal to string, or type of time not equal to a number, we will reject. Okay, yeah, we'll just do a reject without a message. Okay, so let's see if we can't get this to run. So we'll do time logger, and we will give it a message that says first, and we want 1 second for the first run. And we'll say dot then. We will get back some kind of message. So I'm going to say message. And let's try this initially, console log message, just as a sanity check. Run. After a second, we get that message. Cool. Let's throw a catch in here just in case. Error. Console.log error. So if we try to give it something that's a string, for example, not a number, let's see. And I think I know why. It's because I put a semicolon there. And now we should be able to get to that line of code. And oh yeah, we didn't give a reject message, so I'm just going to say incorrect input here, for example. Okay, anyway, let's keep this chain a-rolling. So because I want to return and also log something at the same time, that's why I'm putting in curly brackets here. And now we will return time logger second, and let's say we want it to take 800 milliseconds. Okay. Then we will do another dot then. Just going to call this one message again, and we will console log that message. Let's see what happens. Run. We get first and then second. So it does run in the correct order. Note that if I did not have return statement here, let's see what happens. First, undefined, right? Because we have a dot then here, and we didn't return a promise from the initial dot then. So here it's expecting another promise. So we do want to be sure to return promises. Okay, so same thing here. We can now return time logger third. Let's have this one take 100 milliseconds. It's pretty quick. And we can call it dot then message return time logger fourth 100. Actually, no, let's do 300. And we'll also console log this message. And finally, dot then, let's say message again. This last one, we don't really need to return from it, but I'm going to use these curly brackets and then just do a console.log message. Right, finally, we have our catch just in case we have an incorrect input somewhere. Right, so this looks sort of complicated, but if you consider this compared to our callback hell type situation up above, right, we have callbacks inside other callbacks. Here we can kind of structure that in a way that's kind of more easy to understand. So let's see if it runs. We got first undefined. Looks like it's still on the old code. Let's try that again. We will run it. Okay, first, second, third, fourth. Cool. So they did run in the correct order. Just to do a double sanity check, we should get third, and then pretty close afterwards we should get fourth, even though the time is less. Yeah, cool. Yeah, so it makes sense if you look at it this way, right? So we initially invoke the function, which itself returns a promise. We console log the message, and then we return another promise, which we then wait for, and down the line. Right, so we could chain this as many times as we need to, and we're just invoking the function over and over and over. Next, I'd like to go over kind of a common gotcha that might catch you up when you're just starting out writing promises and asynchronous code using promises. And let's take a look at something here. So I'm going to do promise.resolve, and I'm just going to kind of build a string here with my promises. So we have promise.resolve. We can call .then because we know we can call .then on promises. So we're going to get a string because we get whatever was passed into resolve. So we're going to take that string, and let's say we want to return something. So return string plus space there. And what's happening behind the scenes here is this is effectively same as saying return promise.resolve with whatever you're putting in here, right, which I'm just going to do represent by dots. So this is what happens when you return in a then statement. That's why if you fail to say return, you can't really pass the values along, right, because it's expecting a promise if you want your chaining to work. So here we can grab that, and let's just console log it out. Console.log string. Okay, let's see if this works as intended. We run it, and it looks like it did. Right. On the other hand, if you failed to return it, for example, well, at this point, let's see what happens. Clear, run, undefined. Right? Because we told it to expect a resolve with a string, we're chaining it onto what should be one promise, but we're not actually returning a promise here. So that's why if you fail to return, it doesn't really work. We can, of course, construct new promises as well. We just have to be sure to return them. So we could have written this like this. Return new promise, resolve, reject. And let me get my brackets correct here. Right, if we throw this in there, and then we resolve this. Resolve. Right, let's try that now and see if we are successful. So there we go. So returning a promise. Alternatively, we could have just written it as return like we did initially, or promise.resolve like so. Right, so it's undefined currently because failed to return. There we go. And I think that's important to understand if you have some kind of logic you need to run consecutively, but in an asynchronous manner. So, a little bit high level, but let's take a quick example of that. So here we're returning promise resolve. Let's do an example of asynchronicity again. So we'll do set timeout. And this one doesn't have to be long. We'll just do kind of 1 millisecond here. But in the timeout, we will return a promise.resolve. And instead of an exclamation point, we will do something like that. Okay, let's see if we console log our string. What happens? Undefined. Now, why is it undefined? Well, basically, we didn't know that we had to wait for this set timeout to finish. So we're waiting for this promise to get to us, but at the time we invoke it, even though it's 1 millisecond later, it's undefined. So if we wanted to fix this, well, what we could do is we could do something like return new promise and just wrap everything in a promise. And we can do resolve, reject, and then we can do a set timeout there instead. So set timeout like so. And instead of returning that, let's fix our spacing here a little bit. Instead of returning promise.resolve, well, we can just call resolve at this point. Like so. Okay, let's see what happens at this point, and I will add in my semicolons. Get rid of this space there. Okay, let's see. We wait, and then we can access the string. Right, so it's important to understand that what kind of promise you're returning. If you do have to wait for something, you should probably wrap that entire thing in a promise. Right, so to expand on that example, let's add a space here, and we'll do another .then, take in the string, and let's say you forget to wrap something in a promise, you can do set timeout. And in here, we'll do the same thing, but we will just say string plus equals, we already have a space, so we can just say Chris. And this timeout will also just take 1 millisecond. And let's try a couple things. What if we, outside of our timeout, we tried to return the string? And let me space that over. Like so. Let's see. Clear, run. Hi there. Okay, interesting. What about if we try to return our string inside the timeout function? Let's see what happens. Run, undefined. Right? Again, because it's not waiting. It just doesn't understand that it needs to wait for a bunch of promises to finish first. We're trying to console log something here that technically doesn't exist yet. Right? So asynchronicity does get pretty complicated pretty quick, but thankfully we don't have to deal with callbacks too much with promises around. Now, how can we solve this issue? Well, we could do like we did up above. We could just wrap it all in a new promise. That would definitely work. Okay, we'll clear this over here. And to make sure it's accurate, we will do return new promise, resolve, reject. And we just put all of our logic up above, exactly like we have up in the first then. And then we resolve it, string plus Chris. This one can also take 1 millisecond, so I can get rid of that statement. And let's see if that solved our little issue. Run, and success. Right, we ran it in sequential order because we were returning promises every time. And you know what, this comment, I'm going to move it elsewhere. And I will say return in then, effectively same as saying return promise.resolve. Okay, we'll fix our spacing a bit here as well. And yeah, there we go. Right, so this way, even if this one is 100 milliseconds and this one is 1, we shouldn't fire this before that. Let's test it out. 100 milliseconds, boom, success. The next promise method I would like to go over is called promise.all. And promise.all is pretty interesting. So promise.all, you give it essentially an iterable of promises, like an array full of promises. And promise.all will return a single promise when all those promises it's passed are resolved. So let's see a really simple example here. Let's say const p1 equals, we'll just kind of shorthand it, promise.resolve. This one can say a. We can say const p2 equals promise.resolve b, and const p3 equals promise.resolve c. Now, let's see if we can call a promise all on all of these and see what happens. So we'll do promise.all, and we'll put them into an array like so. So p1, p2, p3. Okay, we'll call it .then, and we get some kind of data back. What is this going to look like? Well, let's console log it out. Console log the data. Okay, we'll clear, run. Interesting, right? So it put it into an array for us. And this is kind of neat because it waits for all of these promises to be resolved before, moving to its then statement. So if, for example, P1 is, let's say P1 is a new promise. So resolve, reject. And this one, we'll do another simulated async action. We'll do a timeout. Okay, this one, let's say it takes 2 seconds, and we will resolve with a again. Let's see what happens. We clear, we run. So this one is waiting until all of these promises are resolved. And if any one of them is rejected, it just rejects the entire promise. So, we can catch that. .catch error, like so. We'll console log the error. And now if we call promise.reject on one of these, let's see what happens. Okay. And showed us C because this was the reason it was rejected. So we'll say rejection here. Right? Run it, rejection. And, it doesn't even run any of these other promises because one of them was rejected. It doesn't matter which one. As long as one is rejected, it rejects the entire thing. Now, why would you want to do this? Well, it could be handy if you're accessing two different APIs, like you're accessing, you're doing a fetch request to one API, and then you're doing another fetch request to another API. And once you get them both back, you need to do some kind of transformative action, for example. Now, why would you want to do this? Well, let's say we have some kind of async action. We'll do P1 and P2, and we could be, say, querying a database or accessing a couple different external APIs, for example. So let's say P1, we'll still do a new promise, we'll still do a set timeout, but we will resolve in 1 second. And we can do something like an object text. This could be some kind of username, so Billy, Bob, for example. So maybe I'll rename this username, and this one can be position, for example. This one will also be a new promise. New promise, resolve, reject. And this one, we will simulate a slow response time or a more than 0 response time. This one will do text as well. And this one can be manager, for example. And this one is a bit faster at 300 milliseconds. Okay, pretty good speed on these servers, these APIs that get back to us. Okay, so we'll do promise all, username, position, and when we get the data back, let's see, what should we do? We can join these two things together. They might be coming from different sources, but we can join it together into an array, for example. So let's do that. So we can say data.map to do so. And we will go over each entry. So I'm just going to call it entry. And we will return, let's see, entry.text, which both of these objects do have that field. Okay, so we're returning a promise here. Therefore, we can say .then content console.log the content, for example, and we can catch any errors that occur. Okay, we wait, and there's our array, which means if we had some kind of data construct, so we had to input this into a separate database somewhere, well, we don't have to write a whole bunch of callbacks and a whole bunch of disparate functions to do that. We can just put everything into promise all. And then let's say we have const employees. Right, we could just do something like employees at position 0 is equal to content. Right, at that point, if we check our employees, console.log employees, let's see. Okay, so it's an object. If we open up our dev tools, uncaught, promise no good, rejected. Interesting. But I can see that we were successful, right? We have an array at index position 0 of the object. And you know what? I suspect this is from possibly some earlier code. Anyway, looks like we're successful. So this is the type of situation where you may get into eventually. And just kind of good to know about. So I will comment this stuff out as well. Okay. Also, we can do kind of a counterpoint to this, which is promise.race. Promise.race. And it's similar in that you give it a bunch of iterables representing promises, and it just finishes, whichever one finishes first, we can run the logic on. So, you know what? I will uncomment these specific lines of code. These resolve at different times, right? This one takes 300 milliseconds. This one takes 1 second or 1,000 milliseconds. So if we pass these into promise.race, let's try it out. So we can do username, position, then we will get something back, whichever one is fastest. So we'll take the data and let's just console log it. Console log the data. And we'll say data.text so we can actually see it here. Run. Okay, manager finished first. Right? Makes sense because this one only takes 300 milliseconds. If you have a bunch of these in here and you don't care which one finishes first, you just want to take, no matter what, just take the first one to finish. This is where you would use promise.race. And this one, just like promise.all, if there's a rejection, it's just going to reject the entire thing. And what I mean by that, let's put a rejection on the slower one here, and we'll see if it even gets to it. Reject. Here, run. And it didn't get to it because we finished our race first. Right? On the other hand, if our reject was faster, so if this was 200 milliseconds versus this one's 300, let's see. Okay, we didn't catch our reject, so it just rejected. Let's throw a catch in here. Error, console.log, error.txt, for example. Let's run it. Okay, this time our error says Billy Bob. Right, so just to make that even more clear, we can say text error. Right, this caused the entire thing to reject. And we'll let our code catch up here. Error. Right, if I make this one longer, let's see. Clear, run, manager.